I do remember. It's a process where electricity is used to cover one type of metal with a thin layer of another type of metal.
Correct. And it is achieved through the process of electrolysis.
Oh yeah, I remember learning about electrolysis too.
Alright then, go on, tell me what you know.
Sure. Electrolysis is a redox process because the cations undergo reduction and the anions undergo oxidation when an electric current is passed through a compound.
Exactly. This results in the discharge of ions into atoms. Thus, electrolysis is simply the decomposition of compounds into elements by the passage of electric current.
I also recall that a compound to be decomposed is either a molten ionic compound or an aqueous solution of ions.
Indeed, that is because the compound needs to have free ions to move under the influence of electricity. Such compounds are called electrolytes.
Yes, and that's all I remember from the top of my head.
Well, that was pretty good already. You will gradually learn all you need to know about electrolysis throughout this session.
Sounds good. So teacher, what will we be starting with?
Let's begin by taking molten lead 2 bromide as the electrolyte, shall we?
Sure.
Here we have a typical setup for electrolytic cells where a chemical change occurs due to electric current. Two inert electrodes, which are carbon electrodes in this case, are connected to the source of direct current through the external circuit. The electrode connected to the positive terminal will become a positive electrode and is called the anode, while the electrode connected to the negative terminal will become a negative electrode and is called the cathode. As you can see here, the two electrodes are dipped into solid salt of lead 2 bromide.
But teacher, you had mentioned molten lead to bromide, but I can see that it is in its solid form here.
That's because we are yet to apply heat to the solid lead 2 bromide to turn it into its molten state.
Ah, okay.
So can you guess what happens to the solid lead 2 bromide when we apply heat?
It will melt, right?
Well, duh, but can you be more specific?
Sure, let me try. The ionic bond between the lead and bromide ions are broken down due to high temperature. Hence, the ions become free to move around inside the crucible. Thus, the circuit becomes complete.
Now that's more like it. Once we apply direct current to the molten lead 2 bromide,
The anion, that is the bromide ion, will move towards the anode, and the cation, that is the lead ion, will move towards the cathode due to its attraction with the opposite charge of the electrode.
good. Can you also describe what happens at the electrodes?
Sure. Once the bromide ion reaches the anode, it gets oxidized into liquid bromine. While doing so, each bromide ion loses one electron to the anode, which then gets transferred to the external circuit.
Right. You can observe this phenomenon when the liquid bromine bubbles off as brown gas near the anode due to the high temperature of the electrolyte.
Oh, wow.
And what about the reaction at the cathode?
When the lead ion reaches the cathode, it will each receive 2 electrons. Hence, the lead ions get reduced into lead atoms. But since the electrolyte is at high temperature due to heating, the lead atoms obtained melt to the bottom of the crucible.
Good explanation. You actually do know quite a lot about electrolysis.
Seems like all I needed was a good lead on this topic.
I see what you did there. Well then, how about we go through the electrolysis of molten zinc chloride?
Sure, I think I can explain this as well.
All right, off you go.
So first and foremost, an electric current is passed through the electrolyte. This causes zinc 2 ions to move toward the cathode, while the chloride ion moves towards the anode. Next, a redox reaction occurs at the 2 electrodes. At the anode, each chloride ion loses one electron to get oxidized to form a neutral chlorine molecule. This bubbles off as pale green gas. At the cathode, each zinc ion gains 2 electrons to get reduced into a neutral zinc atom. Since the temperature of the electrolyte is high because of the heat used to melt zinc 2 chloride, The zinc formed settles at the bottom of the crucible in its molten form.
Excellent.
Thanks. And teacher, I think I'm quite good at figuring out the end products of electrolysis of compounds.
Are you sure about that?
Of course.
All right then. What will be formed at the electrodes if we electrolyze molten lithium chloride?
Lithium at cathode and chlorine gas at anode.
Good. How about molten sodium chloride?
That would be sodium at cathode and chlorine gas at anode. Simple.
Well, those were easy. Let's twist this up a little. What if we electrolyze an aqueous solution of sodium chloride?
Solid sodium at cathode. Wait a minute. Why do I feel like it isn't this straightforward?
You're right. It gets a bit complicated when you electrolyze a solution as water molecules are involved.
But water is not an ionic compound. How can it get electrolyzed?
Though pure water is not an ionic compound, it is a polar covalent molecule. Therefore, dissolving even just a bit of salt or acid increases the conductivity of water to a much greater extent.
I didn't think of it that way. I thought since water molecules ionize very weakly, the probability of it decomposing would also be very low.
That's a very logical way of thinking. But once the ionic compounds are dissolved in it, each ion gets surrounded by the side of water molecules that have the opposite charge to that of the ion. In the solution, the water molecule that moves to the cathode gets reduced to form hydrogen gas and hydroxide ions, while the water molecule that moves to the anode gets oxidized to form oxygen gas and hydrogen ions.
So what you're saying is that in an aqueous solution of ionic compounds, there will also be presence of hydrogen ions and hydroxide ions.
Yes, the hydrogen ions formed get reduced at the cathode into neutral hydrogen gas molecules.
While the hydroxide ions formed get oxidized to produce oxygen gas at the anode. So either hydrogen ions or metal ions are reduced at the cathode to give hydrogen gas and metal respectively, while on the other side, either hydroxide ions or non-metal ions are oxidized at the anode to give oxygen gas or non-metals.
Yes. Now, can you predict which cation and anion will be discharged at the two electrodes?
There seems to be some sort of competition going on between the ions.
There's no competition of any sort. It's actually predetermined.
Really? But how?
It all depends on the position of the ions in the electrochemical series.
I know about the reactivity series of metals, but electrochemical series, no, that's something I hadn't heard before.
It's actually quite similar to the reactivity series. So why don't you first tell me what you know about what a reactivity series is?
Sure. A reactivity series is a series of metals arranged in the order of their reactivities, with the most reactive at the top and the least reactive at the bottom. Also, hydrogen and carbon are placed in between these metals.
You're right. And just like the reactivity series, the electrochemical series is also a series of elements arranged according to their ability to get oxidized in decreasing order or their ability to get reduced in increasing order.
Oh, so in both of the series, the higher you go, the more easily the element is oxidized.
Correct. However, there are slight differences in the arrangement of the metals in the reactivity series and the electrochemical series. But you can still use the reactivity series to predict whether the hydrogen ion or metal ion in the solution will get reduced at the cathode.
I see. Then teacher, what about anions?
For that, you can simply refer to the discharge series for anions.
That means the ease of discharge of cations and anions increases down the series. It isn't as complicated when you learn it this way.
Exactly.
Teacher, I know that the reactivity series is arranged according to the degree of ease of reaction of metal with water and then acid. What about electrochemical series? On what grounds are the elements arranged?
The position of elements in the electrochemical series is determined by their standard electrode potential values, or more precisely, the reduction potential of the ions. It is written as E0.
Standard electrode potential. What is that?
We'll discuss that later in this lesson. For now, let's just focus on what the values really mean, while also predicting the electrolysis product.
All right, I'm all ears.
The more positive the value, the easier it is for the ion of an element to get reduced. And the more negative the value, the easier it is for the ion of an element to get oxidized.
So that means the lower the metal is in the series, the easier it is to reduce its ion.
Yes, by using this information, we can predict which ions in the electrolyte will be preferentially discharged during electrolysis.
Wow, this is so interesting. But teacher, do we really have to memorize all the values?
Not really. The values of the standard electrode potential will be given to you in the exams if required. For your information, these values can also be obtained in the syllabus document under the data section.
I see. That's great to know.
Now, in the electrolysis of an aqueous solution of sodium chloride, the hydrogen ion will get discharged at the cathode into hydrogen gas because the E0 value of hydrogen is more positive than that of sodium. So Divash, what about the product at the anode?
Since anions are negative ions, they have to get oxidized in order to turn neutral. The anion with a lower E0 value is more likely to get discharged.
True. For convenience, we can simply use the discharge series for anions to decide that.
In this case, hydroxide ions will get oxidized and form oxygen gas at the anode, as it lies below the chloride ion in the series.
That is true, but only if the electrolyte is a dilute aqueous solution of sodium chloride.
Hang on, does that mean chloride ions will get discharged at the anode if the aqueous sodium chloride solution is concentrated?
Yes, that's because the E0 values of ions of halogens such as chlorine, bromine and iodine don't have that much difference with that of hydroxide ions. If the concentration of halide salt or hydrogen halide is high in the solution, more halogens are produced at the anode as compared to oxygen gas.
So the conclusion would be that in the electrolysis of dilute aqueous sodium chloride solution, oxygen gas would be formed at the anode, while in a concentrated aqueous solution, chlorine gas would be formed. Understood.
Good. Let me test you further if you have fully understood what we've discussed so far.
Okay, teacher.
What would be the end products of the electrolysis of aqueous sulfuric acid at the two inert electrodes?
In aqueous sulfuric acid, there are hydrogen ions from water as well as hydrogen ions from the acid. Either way, hydrogen gas would be produced at the cathode. As for anions, there are hydroxide ions from water and sulfate ions from acid. Between these two, hydroxide ions are more likely to be discharged to produce oxygen gas at the anode, as sulfate ions lie way above the hydroxide ion in the discharge series for anions.
Exactly. Sulfate ions and nitrate ions are anions that are very difficult to oxidize even in its concentrated solution.
Want to learn more? We have additional learning resources to offer for Cambridge IGCSE and AS A-level subjects. Register now for free.